All right. Yeah. It's on the syllabus, but it's you got to go to Grossmont's website. Then you put /people, and then /Jeff-Waller.
I just go through all the menus and just get.
Or you just go to the. Yeah, that's me. Yeah. Hello. So, what we did yesterday was we realized that if I give you one of these bad boys like here, the best we could do if we ask what's the answers to this is to graph it. That's the quickest way to do it, because that's what a graph is. It says, what are all the answers to this equation? So there's no like answer. There's a collection of answers. And the reason that is because there are two unknowns. So for every value for one of them, the other one's got its own value. You can do that forever. Since there's two unknowns, if I give one more piece of information, I normally can figure out both things. I like it. So for example, somebody give me some answers to this.
10.
Huh?
Oh.
Yeah, 0, -5 is an answer to this, right? Give me another answer to this, not you. Somebody else. 1, -3, right? They're picking a value for x, plugging it in, getting a value for y. And of course that list would go on for the rest of the time, break through this earth, and go through the center of the earth, pop out on the other side. All right, let's not do that, not today. So if I give you another piece of information, like if I say, like what are you gonna say, Jeff? I don't know, man. If I say 3x plus y equals 0. How can I use this?
Y equals 3.
Yeah, so here this says y is this. That's what that says. So when I see a y in this universe of this problem, these are both true. This is 3x plus y, but what am I going to put there? 2x minus 5, because that's what y is. And then I get 5x equals 5. Is that cool? X equals 1. Is that, and then you circle that, you're done?
No.
No.
Simplify.
Just find y.
Yeah, I know x, I got to figure out what y is. Well, if I plug a 1 here, 3 plus y is 0, subtract 3, I get y is -3. So I built it off of this point there. That's how I created this equation. I just made that point work.
Sorry, I kind of generally simplified.
They're okay. All right, so that's kind of later in this course. We're going to have an equation like this. X plus y plus z. How many unknowns are there? 3. So then how many equations am I going to need total? 3. Can somebody give me one answer to this? 0, 0, 7. All right. I like it. Live and let die. No? All right. And then like 3, 4, 0. Or 1, 1, 5. Anything that makes 7 at the end, right? All right, all right. Anyway, that's in our future. So then I have to get 2 more equations so I can figure out which one of these. Or maybe it's another one I haven't put. There's an infinite number. Holy shit. All right, now, we also figured out that if somebody gives me 2 of these, do they always have to have a solution? No. And what would that mean graphically? Because what does this mean about these graphically? If I graph both of these, they will meet there. I love it. Right? They will intersect there.
If they're parallel, they're
Beautiful. So if I have 2 lines that would be parallel if I graphed them, if I try to do it algebraically, they're not going to get me anywhere. What would I end up with if they were parallel? What do I get if I try to solve it? 0 equals 7 or something like that. That's it, trying to tell you that there's, what if I get 1 equals 1? Not all real numbers. Okay, so let's do an example like that. Why do I know it's not all real numbers? Because what do answers have to look like? They have to look like points. So the answer is never a number. You guys with me? When I have two variables, the answer is going to be a point. If there are any answers, they will be points. So what does it mean then if I have, what you got, Jeff? Bless you. Y equals 3x plus 2, and then I've got, do another one, Jeff. I can. 2y minus 6x equals 4. Let's just blindly go into this. So I can rewrite this guy. What do I know from this guy? I know y is this. So I put twice y, but what's y? Ooh, you're a good one. Yeah. So I just rewrote that equation, replacing y with what I know it is. I like it. And now let's do this real quick. Bam, bam. 6x plus 4 minus 6x equals 4. Those die. 4 equals 4. The answer is not all real numbers. What does that mean? What's true about these two? Anybody see what's true about these two?
Oh, they're the same.
They're the same. This one, it happens to be twice that one, right?
Yeah.
On both sides. So they actually, the twos would cancel. They're the same equation. So if I graph this line and then I graph this line, what will be true? Why is that kind of a silly thing to say? If you solve this for y, I want to make sure everybody's with me. Add 6x, divide by 2. They are the same. So if you graph this one, and then you graph this one on the same graph, what's going to be true?
They're on the same line.
And where are they touching?
All over.
All over. That was creepy. They're touching all over.
It was for me.
You guys, so the answer is where the lines intersect, what points they intersect at. So if I plot this line and then this line, they intersect at what points? Every point? No? No. Come on, we can do it. If I plot 3x plus 2, real quick, bang, right? And then plot 3x plus 2, where do they meet? They meet at every point that is on
The line.
the line. There it is. That's the answer. So I can't say all real numbers. That doesn't make sense. I can't say infinite points because that's not specific enough. Because that's a point. Right? So what points specifically? Well, the idea doesn't give a shit about the weirdness of the situation. What's the answer? Where the lines meet. Where do they meet? Every point on that line. It's like this. Did I really give us a second piece of information? I really didn't, right? Which means, what could the answers be? As many as there were originally. What could the answers be here? All that points on the line. So it's still the same. I didn't really improve our. So if I say I'm twice as old as you are, which I hate, it's more likely than I used to be, and then I say, oh, he's half as old as I am. Figure out our ages. Why is that kind of stupid? I said the same thing. If I'm twice as old, he's half as old. I didn't give you two pieces of information, did I? So you can't figure it out. I didn't give you enough information. I said the same thing twice. Thanks, Jeff. All right. No, yes?
So you're 52.
No, God. Let's not do that to me. Bam. All right. Not quite there yet. All right. Blah, 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 blah. Does that make some sense? So again, there's ideas that can't change. Situation, they meet everywhere. Idea, answers where they meet. All right, the answer is all the points on this line. So that's where they meet. Kick ass. Okay, so let's look at that last one on that handout. Let's see here. Turn it on. How needy. Poor little dude. There's just one left. Well, I'm not even turning my phone around now. Too bad, everybody. the last one we didn't do, just to show you evidence that we did like this one. All right, let me give myself more room again. So, there's two things that suck about this. What's the most obvious thing that sucks about this problem? The 1/2, but we could do something about that. If there's a part of the equation you don't like, not always, but most of the time you can kill it. How do I kill it? Multiply everything by 2. And that actually does a second good thing. So then I get 2x plus, bam, y equals 4. Is that cool? Double the x's, double the half of y, so I get a whole y. Double the 2, I get a 4. Now you got two different things you could do. Let me see if anybody, what's one thing I could do? This is still substitution, so I have to know like y equals something, or I could get 2x by itself because isn't 2x in the other equation? So that's an example I showed you yesterday. An example that teachers, we sometimes forget to show you guys. But that is the idea. Can you replace an x term completely with a y term? That's what substitution tries to do. So I could do this. Subtract y, 2x is 4 minus 1. That's what the second equation says. So how do I rewrite the first equation now?
4.
Yeah, where I see 2x, I put 4 minus y. Keep going. Minus 3y.
Equals
Negative 12. So I just wrote this here, but 2x is 4 minus y. I really want you guys to see that. I know that's true because right there it says it's true. And then if I solve this, I get y is 4. So then what's x going to be? Yeah, if I plug a 4 in for y, 2x equals 0, so I get x is 0. Right, if I plug a 4 in for y, 4 minus 4 is 0, is 2x, so x is 0. Is that cool? What happens? Best part.
I don't know.
So let me see. Is everybody cool with this first step where I just solve for 2x? Right? And why did I do that? Because there's a 2x in that first equation. Right? So now I know 2x is 4 minus y. That's what that says. So in the other equation, I can replace 2x with 4 minus y. Right there. Is that cool? So right there, I replaced it. Then I just solve for y. Okay, now, so we're there. The answer to this question has to give me values for every unknown. Y is 4, I got an x in there though. So if I plug, let me show you, I didn't really do the work, but let's do the work. So if I take this second equation, 2x equals 4 minus y, and what did we just figure out y is? 4. So if I put 4 minus 4, 2x is 0, so x is 0. See, right now I know y is 4, so I plug it in, and now I can figure out what x is. So once I know one letter, I can go plug it in anywhere and solve for the other letter.
So I just didn't multiply at the beginning. I just kept 4.5.
Oh, shit.
Yeah.
That'll make it a little bit grosser. You should get the same answer, but it makes it easier to make mistakes.
Yeah, I think I made a mistake. Because I got negative
Now,
3 too.
in case, oh shit, in case anyone is curious,
Not the only one.
I could have done this. So I would double this and get 2x plus y equals 2. 4, Jeff. Good job, buddy. If I solve for y, I get y is 4 minus 2x. Is that cool? And then I could plug this in there, right? So the first time I solve for 2x, because 2x is in the equation. Or I could solve for y, because y is in the equation also. So how do I rewrite that first dude now? First dude is 2x minus 3 times y, but I know y is this mess. I really want you guys to see you have options. solve for the easiest letter to solve for, and then plug it into the other one. I just want you to really understand that you have more flexibility. I don't have to solve for x. I could solve for 2x. When would I want to do that? If the other equation has a 2x. Because then I can just plug in. Do you guys get that? If not, you can always solve for a letter, but I just warn you, sometimes you'll get might be fractions or something. Okay, right. And if you do this, I better get the same answer, or else we could forget all this math stuff and go away because it doesn't work. Everybody's hoping I make a mistake now. Do you see this? Is that cool? And then see how the negative 12s kill each other? Die. So I get 8x is 0, so I get x is 0 like we got before. Too bad, kids. And then if I plug a 0 in, what do I get? For y, y is 4 minus twice 0. So I get y is 4. Just like we got before. Damn. We got to keep doing this math. I left in my y's and my 4's. Exactly the same. Okay, so. Just one new idea for today. God, I keep wanting to say.
Why does it feel like the heater's on in here?
What's that?
It feels like the heater's on.
I know, it probably is. I don't know why. I don't have control over it. And we're not in here long enough for me to worry too much about it. It's called overcompensation.
I think the worst is being in a bus with the windows up and humid heat, no way to no air conditioner.
I was on a bus for 27 hours once. I slept on the bus and I woke up and I couldn't. I was like, shit. This is me. That's when I destroyed my car in Mississippi and I had to get a bus home. And I had my master's degree qualifying exam 2 days after that. So that was exciting. Yeah, Jeff. Good planning on that one.
That sounds fun.
It was great. I failed it, but they let me take it again. And they were like, we understand. It's like, yeah, thank you. Okay. So one little new thing for today, and that's all we're going to do since today's our little short day. We got substitution. I'm not sure exactly how this is. If I have a choice myself, I always choose this other way. But you've got to know how to do both ways. You guys with me? You have to know how to do both. If I ask you to solve a problem using one method and you use the other method, I don't care if you get it right or not, you're losing all the points because I need to make sure you can do both ways. So don't complain about it because I just explained to you what's going to happen. So substitution is kind of like underhanded. It is like the invasion of the body snatchers, where you're just going to replace that subversively, like a spy or something. Elimination is very much in your face. I don't like you, I'm going to kill you. Wow, that's a good soundbite. Hey, Dean. Jeff, all right. Easy step in my house. So, for example, there's one little piece to this that I want to address that I don't hear a lot of students ask, but I know it's got to be somewhere in your head. So x minus y is 7, let's say. Oh, I got to make this work. That would probably be better. All right, I got you. 2x plus y equals 20. Okay, that should work. Yeah, it will. So here's elimination method. Whatever I add to one side, what do I have to do to the other side? Add the same thing. So for example, if I add 7 to this, I have to add 7 to the other side, right? But isn't 7 equal to this?
Yes.
So if I add 7 to this side, I can add this to this side, and I did do the same thing to both sides. So personally, somebody's looking at me like, what are you doing? So do you kind of get that? What is 7? In this problem, it is x minus y.
Yes.
And we know I can't change this idea. If I add something to one side of an equation, I must add the same thing to the other side. But isn't 7 equal to x minus y? So if I add 7 to this side, I can add x minus y to this side.
Yes.
You guys, okay, I got you. but not everybody agrees with me, but yes, maybe? So I'm not violating that basic principle. Now, why the shit do I want to do that? Yay, Jeff, you can, but why would I want to? What happens if I do add these stuff together? What happens? The y's cancel. I kill it. I'm like, there's too many damn variables. Let me kill one of them. The only good variable. Dead variable. Yeah. I don't know, you know what movie that's from? It's not exactly the right. It wasn't talking about variables, but it liked that it started with a V.
I'm pretty sure he was.
X, maybe so. You had some issues with math. And math. X and 2x, 3x. So this is why you're allowed to just add equations. And on one level, I always thought students have to be like, why the shit can we all of a sudden do that? But I am not violating the most basic idea of equations. I've got to do the same thing to both sides. I am doing the same thing to both sides. And those died, so now I can solve for x.
Oh, so if the top one was 2x, then those would cancel out as well.
Yeah, but if it was negative 2x.
Ah, okay.
I like it.
-2x. Okay.
So is it always going to be in a situation where something's going to die? No, but you can set it up. You can set things up so somebody dies. Yeah. We could be like a mob boss or something. Yeah.
Like an X.
All you gotta do is stand next to each other. I don't know where.
We'll get a bet.
Think about it, boom, he's dead. All right. So x is 9, and then what do you have to do?
Plug in 9.
Plug it in. So if I'm plugging in this guy, 9 minus y equals 7. Yeah, you can just see it, right? Some equations you should be able to just step out of and go, 9 minus freaking 2, okay, y is 2. Or subtract 9 divided by negative 1. So then, what's another way I can write that? That's fine.
9 comma 2.
9 comma 2. Kick ass, because that's the point where they would meet. The two lines. So elimination method is my personally preferred method. Not just because then I can pretend like I'm in the criminal underground, but it's just very direct.
I bet the people in New Jersey and New York really didn't like that comment.
Oh well. They got a problem with it, come see me. So what have I had? What's wrong with this one here then if I want to try it this way? Forget about it.
That's what's going to happen when I finish this course. I'm going to forget about it.
Don't say it too much. All right. Now you made me forget my.
It's a curse.
Yeah. That'll work. Ooh, I like this one. This is gross. So why wouldn't I just go ahead and add these the way they are?
Because they'll not be answers.
Nothing happens. So don't add things unless it's actually going to accomplish something, right? So how can I set this up? What's the easiest variable to make die?
X.
The x, because I only have to do something to one of the equations then. I can make this one, what needs to be here so that these will die?
Negative 4.
Negative 4. I can't just make this a negative 4. I love my people that are like, they just erase this and put a negative 4 there. No, that's illegal. What do I have to do to this equation to make this become negative 4? So let me rewrite. I'm going to leave one alone. He's fine just how he is. Take 2 and multiply by, what'd you say?
Negative 2.
Negative 2. So I get negative 4x
Plus 10y.
plus 10y
Equals 14.
equals 14. Positive 14 only. You guys with me? Now that's a really easy place to make some negative mistakes, but that's why I like to do this. Just go there, there, there. Tell myself what I'm doing, and then make sure I actually do it. Right? No, yes? You guys all right? God, I can't read. Some of you guys can't read. And then, thankfully, Jeff made a problem that works. Right, these will die. This is 13y equals 13. Jeff really is going out on a limb there.
Come on. No.
If I'm making it in my head, I'm going to stick with like 1 or something. You know I can do better, but I don't want to. So y is 1. How do I get x?
Plug it in.
Plug it in where?
The top one, because it's not negative.
It doesn't matter. Yeah, that's a nice. It's a negative that could mess me up, but that negative is on the thing, so it doesn't really matter. So if I do the second one, 2x minus 5 times 1, because I know y is 1, equals -7, so I get 2x, add the 5, -2, I get x is -1. You would get the exact same answer if you use the other equation, because again, this is where they meet. This is where they agree, so they should be the same.
They agree, they shake hands.
Put it there. All right. And again, I could put it as -1, 1 if I felt like it. Yes?
Were you gonna X minus 2?
Which one, sorry? Oh, here. Okay. Why did this one work? Because it was set up so that the coefficients on the y were opposites. So that if I add them, they die. This equation, nothing cancels. But if I multiply this by -2, won't it become -4 and kill this guy? That's the idea. So if I multiply this equation by -2, now these die. As they should. All right. What time is it?
1.
1. All right. One more example of this, and then we'll do a couple off of this other handout I've got.
I don't like to know the time, makes it go long.
What? You don't? Sorry. I'll try to motion to you to cover yours. So what about this one? Are you working today? Let's see. All right, let's see, Jeff. I don't know, man. Oh, shit. Yeah, let's do that.
You can do it, buddy.
Oh, thanks. I've already forgotten what the hell it was. Shit. Oh, yeah.
28.
Why do you want the most disgusting
Why?
numbers?
Just, maybe he'll do it one day, you know?
Okay. Yeah, that'll work. I like it. What do you think I'm doing up there? What am I doing? How do I create this? What do you think I do?
Work backwards.
Yeah, I start with the answer. So I picked a value for y and x, and then I just write these, and then I figure out what it would be once I plugged them in. So I construct it having an answer. So let's see if I actually did this right. What's really gross about this?
There's no easy coefficient.
Yeah, there's nothing that becomes the other number. So this is very much, I don't want to make you, all right, screw it. This is like denominators. It is, right? Because I'm trying to multiply both things up so they agree. Over there was easy because they just needed him to become him, and yay. Here, shit. So it doesn't really matter. I mean, which letter do you want to die? You want to kill the Y? Okay. Y is kind of shady. Keep solving for this dude. It's like, come on, man. So LCD of 5 and 4 would be 20. Yeah. So you just, what do you got to multiply him by? 4. And the nice thing is they already have different signs. If they were both positive, you have to multiply one of them by a negative so that they will cancel when you add. I like it. So then here I get 20 y
Oh,
minus 28 x equals 12. And then here times who? 5. So then I get
Negative 20.
negative 20y, thankfully,
Plus 15x.
plus 15x,
Equals -25.
negative 25. What? Do you see that? So you don't have to think of it as LCD if you don't want to. But it is the same idea. It's what can these both multiply up to become? Do you always have to do both? Well, no. In the first one, we didn't have to do shit. It was already set up. So here what happens? You
15, negative 13x equals negative 13. 1.
but if you plug a 1 in, doesn't matter which one. But I would probably use the first one. Sort of like Holly's idea, there's a negative there that might mess me up. I get to choose. So if I put it into the first one, I know x is 1, so 5y minus 7 times 1 equals 3. Add 7. 5y equals 10. Y equals?
2.
Oh, look at that, Jeff, really going out on the limb. Watch out. Stand back, yes.
Negative 15. You multiplied those, right?
Which one, sorry?
The top two.
Yeah, by 4. I had to multiply this one by 4 and this one by 5, so they both become 20. One of them is negative, so I knew they would cancel right here. That's what I'm working towards. If nothing cancels immediately by adding them as they are, you have to multiply at least one of them up so that they will cancel. So it
And that
is just
becomes-
like the idea of LCD.
That becomes 12 because of the negative.
We looking here?
Yeah.
4 times 3, 12.
Yeah.
And then I multiply this one by 5. 5 times that, 5 times that, 5 times that.
Ah, okay.
So however you want to write it so that you don't forget everything get multiplied, right? One of the biggest mistakes I see is these numbers don't change, and then you get funky ass answers. So don't do that to yourself.
I think I would have made the mistake because I kind of saw them as one equation on accident. That's what I saw
Oh.
instead of two separate ones. So I probably did that.
Yeah, be careful about that. So let me give you this. Where are you? Oh, Jason. There you are. If I was you, I was probably rooting that I wouldn't find it. So let's see where it says section 5.3. We're not going to worry about the word problems yet. There's some word problems on here. Yeah, buddy. So in case you were concerned that we left them behind, they're always with us. That's the word I'm using. I don't think that word means what you think it means. Inconceivable. What?
Yeah, I've got a terrible question for you. Why doesn't X equal 0?
All right, give me a second. So why do you think x would equal 0? I don't know why I did that.
Because at the end you got 13 to get X, right?
No. What are these two doing? What's the operation right here? So you have to divide by negative 13 to get rid of it.
Okay.
If I try to add 13, they're not like terms. Nothing would happen. So you look at the operation that's happening and you undo that operation. Your brain is going to say the opposite of negative 13 is plus 13. But it's the operation that you have to kill. So really, what did I do to that? The operation is multiplication. So you have to divide.
And people forget about the invisible one that's next to the X. So.
Cool. But it's really, your brain sees negative 13 and thinks plus 13 is the opposite, but it's not the opposite operation. That's what's important. All right.